Types of data. Data is a collection of facts and statistics that are gathered together for the purpose of reference or analysis. Data allows us to learn more about various phenomena and processes. In statistics, observations and variables are fundamental concepts that help describe and organize data. When we try to understand a phenomenon, a process, or a problem, we gather information. Each piece of information we collect data about is an observation. An observation could also be a product, a social media campaign, a business, or even a society, a population, or a culture. We often measure several aspects of each observation, which we call variables. We use data to record our observations. Take a look at this example. If we are interested in finding out what the students' preferred beverages are on campus, we will collect data from a selected group of students. Each observation will be a person. Age, sex, and beverage preference can all be stored as variables. For each observation, we record a score or value for each of the variables. When we store this data in a spreadsheet or database, each row corresponds to a single observation, and each column is a variable. Now, there are different levels of measurement for variables, and they determine what kind of analysis and summary statistics we can use. In statistics, data is categorized depending on the level of measurement. The higher the level of measurement, the more statistical tests you can run on the data. Data can be broadly classified into categorical and numerical data. Categorical data is further classified into nominal and ordinal data. Numerical data is further classified into interval and ratio data. Categorical data, also known as nominal data, represents categories or groups. It consists of distinct categories that do not have a natural order or numerical value associated with them. Numerical data, also known as quantitative data, represents measurable quantities and has a natural order. Let's discuss the different data types one by one and discover their applications. The most basic type of data is called nominal data, which is also known as categorical data, as numbers can represent categories. Nominal data represent categories or labels that cannot be quantitatively compared. They are used to name or label a series of values. In nominal data, the categories are distinct and separate, and there is no meaningful way to compare or quantify the differences between them. You cannot perform mathematical operations like addition or subtraction on nominal data because there is no meaningful numerical value associated with the categories. Eye color is a classic example of nominal data. People's eye colors are categorized into distinct groups such as brown, blue, green, hazel, and gray. These categories do not have a natural order or numerical value associated with them. Instead, they represent different labels for a specific characteristic. A team's jersey number is a good example of nominal data. The number merely identifies a player but doesn't hold any arithmetic value. Other examples include gender, marital status, religion, hair color, type of car, etc. Nominal data is often used in statistics and data analysis to group and categorize information for descriptive and organizational purposes. It is typically used to classify, group, or label items or observations. The numbers in nominal data are not used to perform arithmetic operations. We represent nominal data using frequencies or percentages. But calculating a mean for this type of data isn't meaningful. The next type of data is called ordinal data. Ordinal data is a type of categorical data that represents categories with a specific order or ranking. Ordinal data have a meaningful order or ranking among the values but the intervals between the levels are not necessarily equal or known. In ordinal data, categories have a meaningful sequence or order, but the exact differences between them may not be well defined or equal. In education level, categories like high school diploma, associate's degree, bachelor's degree, master's degree, and doctorate represent ordinal data. They have a clear order in terms of educational attainment, but the difference in knowledge or skills between these categories is not uniform. A clothing store's size chart is another example of ordinal data. When you see a higher number like large, it means the item is bigger, and when you see a lower number like small, it means the item is smaller. However, the differences between the numbers in ordinal data do not have any meaningful units of measure. We cannot conclude that the size of medium is 2 times larger than small. Ordinal data is used in various fields and contexts where the order of the values is significant, but the exact differences between them are not necessarily consistent or known, such as in Likert scales and satisfaction ratings. Interval data is another type of data which falls under quantitative data or numerical data. Interval data are numeric scales in which both order and the exact difference between values are known. But there is no true 0 point, which is the complete absence of a particular attribute. Interval data can be measured and involves numbers like age and weight. We see that the differences between numbers begin to have meaning. It is characterized by having equal intervals between values, meaning that the difference between any two data points is meaningful and consistent. Interval data has equal interval units of measure, making it comparable across different points on the scale. But 0 does not mean the lowest point of measurement. IQ, intelligence quotient, scores are often considered interval data. The interval between an IQ score of 90 and 100 is the same as the interval between 110 and 120. However, an IQ score of 0 does not represent the absence of intelligence, as the 0 point is arbitrary. The ratios between IQ scores are not meaningful in the sense that an IQ of 120 is not twice as intelligent as an IQ of 60. Temperature is also considered an example of interval data. The temperature scales, such as Celsius and Fahrenheit, are examples of interval data. The difference between 20 degrees Celsius and 30 degrees Celsius is the same as the difference between 30 degrees Celsius and 40 degrees Celsius. However, 0 degrees Celsius or 0 degree Fahrenheit doesn't mean an absence of temperature. It's just an arbitrary point on the scale. You can't say that 40 degrees Celsius is twice as hot as 20 degrees Celsius. Interval data is found in varied fields, like in psychology for psychometric assessments and geography for climatological measurements. The fourth type of data is ratio data, which is categorized under numerical data. Ratio data have all the properties of interval data, plus a true 0 point. For ratio levels of measurement, the divisions between the points on the scale have an exact value, and the 0 point is non-arbitrary. 0 point refers to the point on a measurement scale where the value represents the complete absence of the attribute being measured. With a meaningful 0 point, we can make statements like twice as much as or half as much as. Weight, height, pulse, blood pressure, time, and temperature on the Kelvin scale are all examples of ratio data because they have a meaningful 0 point. In weight, a value of 0 indicates the complete absence of weight or mass, making it possible to say that 10 kg is twice as heavy as 5 kg. Similarly, in height, a value of 0 represents no height, enabling us to make meaningful statements like someone who is 180 centimeter tall is twice as tall as someone who is 90 centimeter tall. Ratio data is used in almost every field since it allows us to make meaningful comparisons and statements about magnitudes and ratios, making it a powerful type of data for analysis and decision making. Data is categorized based on the kind of variables found in the data and the nature of the data. You have now learned about the different types of data in data analysis, which are nominal, ordinal, interval, and ratio data.